Let us look at another example. In this case, we're going to look at a structure that is a little more complicated because the structure has many elements, as element AB, AD, DB, BE, and EC, plus the one from BC and D to E. They're asking us to use the method of joints to determine the force in each member. So what they're asking is, what is Cx, Cy? They're asking for A, D, so force from A to D, which is the same as the force from D to A. It's basically this one. We don't know yet if it's in compression or tension. Basically, if it's stretching or compressing the element. The force from A to B, which is the same as the force from B to A. The force from D to B, which is the same as the force from B to D. The force from D to E, which is the same as the force from E to D. B to E, force B to E, which is the same as E to B. B to C, force B to C, which is the same as force C to B. And lastly, E to C, which is the same as C to E. Okay, they're asking us for all the forces here. Luckily, we can start by doing the full system analysis, which is decoupling these restrictions or the supports and finding Cx and E and Cy. To do that, we can do a summation of forces. So first of all, we know that this is the case because here we have a fixed support, Cy, and here we have a roller, and the roller is a single force. It's not fixed like C. So we saw that already. It's free to move with certain friction from left to right, but it cannot move in concept or in theory from vertically. That's why it's supported. Plus all these forces are keeping it static in the vertical direction. So let's find Cx, I mean. Summation of forces in X equals, at this point, equals 0. At this point, we do the whole structure. We don't break the elements yet. And the only one we have is Cx equals 0. Okay, so we have the first force here. Okay, that was pretty easy. Then if we do a moment around C, we can cancel Cy and Cx and find E. So summation of moments around C, remember in Y was positive going up, and moments around C is positive counterclockwise. Okay, so summation of moments around C, let me fix this a little. Summation of moments around C equals 0 clockwise, and A is giving a force moment that is counterclockwise, which is positive in our case, clockwise is negative. So counterclockwise we have 2,000 force times 24 feet plus 1,000, which is B, times 12 minus, because it's clockwise, E times 6 equals to 0. That will tell us that E is equal to 2,000 times 24 plus 1000 times 12, 12,000. 1, 2, 3, 12. Okay, and this whole thing divided by 6. Let's see, are we doing this correctly? 12 is 2000 times 24 plus 1000 times 12 divided by 6. Yes, so that is 10,000. Pound force times C. No, this is not. Yeah, this is force. Why? Because this is basically E equals 2000 times 24 plus 1000 times 12 divided by 6. That's what we have computed, and that is 10,000 positive. So E, actually E is missing here, is 10,000 pound force. All right, now we need to do Cy, which is pretty simple because now we have all the forces in Y except for Cy. So summation of forces in Y, whoops, in X. In X is not going up. In X is going horizontally to the right. Right, okay. In Y is going up positive, equals 0. So Cy is going up. That's how we defined it. E is going up plus 10,000 I mean, minus 2,000 minus 1,000 equals 0. So Cy equals 3,000 minus 10,000, which is equal to negative 7,000 pounds. So this force is actually in compression, or is pointing down. Cy. All right, so we have negative 7,000 pound force. Okay, so we have all the forces from the external, from the boundaries. We have E, Cx, Cy. 0, this is 10,000, and this is negative 7,000. Okay, good. Now we need to start finding A to D and A to B, and we can start from whichever point, but I think it's simpler if we start from, say, A to B. So A, B, D, element A, B, D. So that would be 12 point D, which is at 6. Okay, so and this is 8. So if you notice, we have a vector pointing down at A, right? So this vector, we can move it here, or we can move it here, whichever we want to do. So this is originally placed here, but remember we can move vectors around. That was chapter 1. And the dimensions right here are 6, 8, and this L would be L squared equals 6 squared plus 8 squared. This is equal to 64 plus 36. L is square root of 100. Therefore, L is 10. So L, this is 10. Okay, so once we put the force here A, which A was 2000, so this is A. Again, if you move it here, it will be the same case. It will just be, this distance will have to be 6. All right, so we have a triangle where we can actually find this angle here if we wanted. And the way to do that is with the cosine. Okay, so cosine of theta is equal to 6 over 10, or 3 over 5. So theta is cosine inverse of 3 over 5. So let's do that right now. Cosine, parenthesis minus 1, of 3 divided by 5. And that is 53.13 degrees. Okay, so if this is theta and this is also theta, and that we can find alpha. So that means that alpha plus theta equals 180. In other words, alpha equals 180 minus 2 theta, which is equal to 180 minus 2 times this. 180 minus 2 times this. Right, minus 53.13, 783.74. So this angle alpha is equal to 73.74. Okay, so that's important because that will help us find the forces. Because remember that right here we have point A, B, and D. A, B, D. Meaning that this is force A to B, or force B to A. This is force B to D, and this is force A to D. So since we have the angles, we can find the forces pretty easy. So let's start with what we know, A. So let's use A to find the force A to D. So remember, we can use the ratio here. So A is to 8. Same way that the ratio between A and 8 is the same ratio as FA to D to 10. So FA to D is equal to 2000 times 10 divided by 8. This is, let's use the calculator. 1, 2, 3 times 10 is 20,000 divided by 8. This is, oops, 2,500 positive. Well, actually, let's see. It is not positive because we have a negative 2,000 here. So this is negative 2,000. So this is negative 2,500, right? Because we have to remember that we have to carry the magnitude and direction of the force. So be careful with that point. I will give you wrong answers. So we'll give you the right magnitude, but not the right direction. So FA to D is the same as FD to A, which is negative 2,500 2500, which that means is that we have 2500 pound force compression. So this is shrinking, not stretching. Okay, so that's another one that we found. We have F A to D, and in that case we have a triangle, a triangular shape, which has a magnitude of 2500, and which one do we know? We don't know A to B, and we don't know B to D yet, but we have the lengths. So 2500, and we have, this is the magnitude of this whole vector, and we have that this is 12. Alright, and then we have that this is 53.13, and this is 73.14, 0.74, I mean, 0.74, and this is 53.13. So we can use the law of sine, or the sine law, which means that we can use negative 2500. Let's try to find F A to B. The ratio of 2500 with sine of 53.13 is the same ratio of F A to B with respect to sine of 73.74. And that will tell us that F A to B is equal to, let's see, so sine 73.74 times negative 2500 divided by sine of 53.13. This is negative 3000. Alright, so we found another one, which is B to A or A to B, negative 3000. Okay. Alright, let's see what else we can find. Then we're missing F, B to D. Oh, and this one is pretty simple. I can already see why. So let's use negative 2500. If we have that F, A to B, which is negative 2500, that the ratio of A to B with respect to sine of 5313, with respect to sine of that angle, has to be equal to F B to D with respect to sine of 53.13. Cancel, cancel, meaning that F A to B is equal to F B to D. That is very good because we already have A to B. So, sorry, we already have A to D. This is A to D. This is A to F A to D. And F A to D was negative 2500. So we have A to D, and we have D to B, and we also found A to B. So we have all the elements right here. Okay, so with those elements, we can move to point B or to point D, whichever we want to do. Let's move to point B. Well, actually, D has 1, 2, 3. Let's do D, because we already have 2 out of the 3 forces from D. So, point D. So that would be triangle DBE. Triangle DBE, remember, started from D. It went to E. No, sorry, it went to B. We'll check here in a minute. And then it went to E. Let's check. Yeah. Let's bring this down here. All right. Yeah, DBE. Okay. So that means that if you notice, it's 12, and this is still at 6. So this is still 12, and this is still 8. So this is still 10. So this is still 53.13. 53.13. This is 73.74. Right? Is that what we found earlier? Yes. So with that, we have D to B. And D to B was, let's grab the right one, D to B, D to B. Yeah, I thought we had D to B. Yes, it's negative 2500. This is D. And this is D. Negative 2500. So in this case, we're gonna get the opposite, which is 2500. All right, we're gonna get the opposite side. So we need to find F D to E, and we need to find F B to E. We need to find these forces right here. Okay, so for that, we can basically do the same concept that we've been doing, is law, sine law, which is pretty simple. So 2500, let's first focus on point D. We're actually missing something here. We're missing that point D has, yeah, we're missing a force. We're missing a force here. We're missing the force from F A to D. The force from A to D, which we already have. F A D. Okay, so we have this force, and we need to find that force. Actually, D to B we already have. We need to find this force. Okay, so let's focus on that one first. Let's try to find that force, the force from D to E. All right, and for that it's pretty simple because we already have this angle. This angle is 73.74. and this is F D to E. We have this, we have that, we need to do F D to E. Alright, so F D to E is pretty simple. We can use just the triangular shape that we had here. Yeah, let's do that. Okay, so this is 73.74. The only one we're missing is this one. So let's do that. F D to E over sine of 73.74 is equal to F D to B over sine of 53.13 degrees. Right, because it's D to B and this is 53.13 degrees. Okay, so in that case, we just need to compute F D to E based on F D to B, which that is basically F D to E is equal to F D to B, which we had up here, D to B is negative 2500 negative 2500 times sine of 73.74 divided by sine of 53.13. Alright, let's do this computation. So 2500 times sine of 73.74 divided by sine of 53.13 is 3000 FD2E. Okay, so this is 3000 pound force and is negative, so it's in compression as well. So FD2E is equal to negative 3000 pound force. Okay, we have D2E as well. Is in compression then. Whoops, it's not D2E, it's D2E. Alright, now we can find B2E. If we go here, we move to point E, but now point E is not based on the elements alone, it's based on the force as well. So if you notice, we have E and B and E, yeah, we have everything. So we go to point E. In this case, we have a force coming up of 10,000. This force was given to us, so this is the column or the support. Okay, and we have a force of negative 3,000, and the force D B to E. Do we actually have B to E or not? We don't have B to E, do we? B to E. No, we don't have B to E. Okay. So we have to compute B to E first. So actually what we need to do is compute point B first. Point B. Alright, so at point B we have a force of negative 1000. We have a force of A to B, which that force A to B is negative 3,000. Negative 3,000. And we have the force B D to B. So we have to draw that one too. 3,000. And D to B is, let's check. D to B is negative 2,500. Okay. And then we have B to C, which we don't have. And then we have force B to E, which we don't have. So from here we can find B to E and B to C. How? Well, summation of forces in X and Y. So if we do summation of forces in X, this one could be found, and summation of forces in Y, this one could be found. So let's do that one first. So for summation of forces in X, or I mean in Y first, equals 0 when up is positive. We're gonna have the contribution of negative 1,000, which was given by the problem, and then we're gonna need dimensions here. So this is a length of 10, and this is a length of 8. Okay, so for y will be minus 2,500 times 8 over 10, or sine of 23, or sine of 53.13. Okay, so we have negative 1,000, negative 2,500 times sine of 53.13, which is the same as 8.10, 8 divided by 10, and the force of B to E, which is the one that we're finding. B to C and negative 3,000 are in X. We'll take care of that in a minute. And this one is also minus 8 divided by 10 times force B to B. So 0 equals. Alright, in that case, we just need to find B to E times A divided by 10 is equal to negative 1,000 minus 2,500 times A divided by 10. 2,500 times 8 divided by 10 is 2,000 minus 2,000. So force B, this is force B to E. So let's see, force B to E is equal to negative 3,000 times 10 divided by 8, which is equal to, so 2,000 times 10 divided by 8, 2,500. 2,500. So let's double check. So let's double check. This is negative 1,000. Yep. Negative 2,500 times 8. Okay. So why is it giving me so little? 25 is, well, is, why is it the same? I have a force here. Let me try again. Minus 1,000 minus 2,500 times 8 divided by 10. Okay, that is negative 3,000, and then times 10 divided by 8 times 10 divided by 8. 3750. Yeah, I had something wrong here. All right, so we have the negative Well, 3750. Negative 3750. But I should have gotten that with this. So 3000 times 10 divided by 8. Yeah, 3750. I must have typed 2000. Okay, 3750. And 3750 is force B2E. Negative 3750 pound force. All right. So we have FB2E, which is the same as FB2B. Okay, now that we have this force, we can compute B to C. And in order to compute B to C, we simply do a summation of forces NX. So over FB to C. Summation of forces NX equals 0. We're going to take everything positive going horizontally to the right. That means that FBC minus 3000, and then 1000 doesn't come into the equation because it's going in Y, but negative 2500 does. Cosine of 53.13, or this is 6, because the whole triangle is 12, therefore this is 6. This base all the way to this point is 12, half of it is 6. And we're going to do cosine, so it's 6 divided by 10 plus FB to E, 4750, which is going to the right, times 6 divided by 10. So we have summation of forces of B to C, which is the one we're trying to find, negative 3000 minus 2500, 6 over 10, plus 3750, 6 over 10. Alright, so in that case, all that is equal to 0. What we need to do is find that f B to C is equal to, everything to the right hand side, 3000 minus 2500 times 6 divided by 10, 1500 minus, to the other side of the equation, 3750, 2250, and FBC is, yeah. Alright, so this is equal to 3000 minus 1500 minus 2250 is negative 750. FB to C is negative 750. Pound force. Okay, so this is negative 3000. Let's double check. FB to C minus negative 3000 minus 2500 minus 3750. Yes. Okay, so that means that B to C is equal to negative 750 pound force. Okay, and this is FE to C is equal to, all right, we have to do one more point, which is E to C. For E to C, we take point E again. In point E, we have a force coming up of 10,000, a force from D to E, a force from E, this is point E. So a force from E to C, which is the one we're trying to find, and a force from E to B. Right, because we have a point B up here. Okay, so B to C. Oh, actually, we don't have to take into account B to C, so it's E to B. And E to B was negative 3750. All right, this point here was D to E, and D to E was, we should have found it over here, it is negative 3000, or in this case going up, right, so 3000. And yeah, with that info we can find F E to C. Okay, so we have to do the same thing. Summation of forces in X equals to 0, and summation of forces in Y equals to 0. Alright, so in summation of forces in X, we can do so what do we have in X? We have the contribution of FD to E, so 3000 plus, right, we're going to be positive to the right, 3750, and then what is this? This is going to be 8, and this is 10. We found that at the very beginning. This height is 10. Sorry, this height is 8 from here to here, and the length of each element is 10, because the halfway point is 6. So we don't have to do that again. We know that that's 10. And that force is 3750, so 3750, and we're trying to do with respect to X, so since this is 6, is times 6 over 10, and then we find FE to C, and that is plus FE to C times 6 over 10 equals to 0. So FE to C times 6 over 10 is equal to negative 3000 minus 3750 times 6 over 10. Alright, so that is negative 3000 minus 3750 times 6 divided by 10, negative 5250 10 times negative 5250 divided by 6. So negative 5250 times 10 divided by 6 is negative 8750 times of force. Okay, so this is equal to negative 8750. So they're telling us basically that everything is in compression, which should not be the case. So what is here in, let's see, I'm finding that 2500, I think I have a typo here. If A to B FA to B, sorry, AD is negative 2000. Yup. So this one is in compression. Okay, so if this one is in compression, this one is in tension. Okay, so FA to B is positive. Since FA to D we found, yes, this one is going in tension. So this is positive, 2500. So A to B is positive. FA to B is positive. A to B is positive. FB to C is, let's see, FB to C. FB to C. FB to C, we have negative 3000, negative, yeah, so this one is positive and the rest are negative. Okay, so let's check. Okay, let us check. So we have E is equal to 10,000. We have E equals to 10,000. Where do we have E? Yes, E is 10,000. Okay. Cx0, Cy is negative 7,000. Yes. Cx0, yes, that was pretty easy. All right, FAB is 1500. FAB is 1500. FAB is 1500. They're saying it's 1500. I'm saying it's 3000. FAB is 1400. Why? Because they're doing 2000, which is the force at A divided by 4. Yeah, which is, yeah, this is the ratio of 8, 6, 10. Yeah, but they're finding, so there's a typo right here for them. They're finding the force with respect to half, but the force is twice as that. So they have a typo because that element is not, that element is not a 6 bit. That element is a 12. Yeah, so they have a typo there. So this one is wrong. And they're saying it's in tension. Yes, we're saying it's in tension. So A to D is, which one? They're doing A to B. What do they get for A to D? A to D is 2500 in compression. We got negative 2500, so A to D is perfect. So D to B should be in tension since A to D is in compression. Let's check. So A to D, D to B is in tension, 2500. So I have a typo, D to B is in tension because A to D is in compression, therefore this one is stretching since it's the same concept. So D to B is 2500 in tension. They have D to B is 2500. D to E, they have 3000. D to E, we have 3000. Yep. And compression, D to E is, yep. B to E, which is the point from here to, all right, B to E is cross section here. B to E is 3750 in compression. B to E, we got 37 in compression, very good. Then they're doing B to C. B to C, we got negative 750 in compression. They got 5250, but they're using this 1500, which is incorrect. So this should be negative 3000. Negative 3000. So this is incorrect. And yeah, this is incorrect. They're using 1500 where that is a typo they have. Okay, FE to C is negative A750. Yep. That's correct. So in other words, they have B to C as 50 to 50, and they have A to D as 1500, but that is not true. The whole triangle is 12, 8, and 10. So they're just using half of this. So really, this is the answer. We have B to A in tension, so this force is in tension. D to B is also in tension, and everything else is in compression.